Would you rather receive $10 million right now or receive pennies every day of the month, where each subsequent day you receive double the amount of pennies you received the day before? In pennies, we're going to prove why you should definitely take the pennies. Your job is to write pennies.c, a program that first asks the user how many days there are in the month, and then asks how many pennies the user will receive on the first day. The program should then calculate the amount that the user will have accumulated at the end of the month and display it. We can break this program up into a couple of tasks. We'll need to prompt for multiple user inputs, days in month and pennies on first day. We need to keep track of how much money the user has and update it every day, doubling the amount of pennies that they receive. And finally, we print their final total in dollars. Let's tackle user input first. I'm going to open up apples.c, a short program that deals with inputs and outputs. At the top here, I've included some of the libraries that I need, CS50's library and the standard IO library. I print a prompt using the printf function from the standard IO library, but the actual prompting of the user happens in the next line with this getInt function in the CS50 library. GetInt obtains input from the user and ensures that the input is an integer. So I store the user's input in the integer I, subtract 1 from I, and then print out the new value of I. After compiling apples.c using the command makeapples, I have an executable file, apples. Running that, I'll input 1. The program tells me that I have 0 apples left, and so that worked as expected. So let's run this again and input -1. Now, having a negative amount of apples doesn't really make sense, but the program accepts it because -1, well, it is an integer. And now the program, or the monster inside the program, eats a negative apple, and now I have -2 apples. So that's one lesson. Even though the getInt function and related functions like getFloat or getString get us the right data type, you have to make sure that the input makes sense for your program. In pennies, it won't do just a prompt for an integer. You'll need to make sure that the user inputs an integer that makes sense given the context. Months can only have 28, 29, 30, or 31 days. We want to continuously demand a valid integer. If they input an integer outside of our accepted bounds, we'll prompt them again and again until they give us a valid integer. Recall the repeat until block in Scratch? You can make a similar construct in C using a while loop or do while loop. The while loop structure has a condition that must be met for the body of the loop to execute. This should look a little similar because the condition is just like the Scratch blocks with the angles and goes into the brackets of the while loop. So that condition will check whether the integer is within the appropriate bounds. You can prompt the integer using getInt and then execute your while loop, repeating the prompt and printing instructions while the input is not valid. Another way to ensure correct user input is by using a do while loop, which is very similar to a while loop. The do while loop executes the code inside the body once and then checks whether the condition is met or not. This is useful for obtaining user input because you know that you need to prompt them at least once. If the condition is not met, the program will execute the line after your do while loop. If the condition is met, though, the loop will repeat. A do while loop for validating user input will look something like this. I declare a variable n, getInt, and then repeat until n is valid. And this process I explained was using the integer data type, which you'll use for the days of the month, but we know that the number of pennies will pile up quickly. So in order to store larger numbers, use the data type long. But remember, the same principle of validation applies. Awesome. So once we have 2 valid inputs from the user, days in the month and the pennies on the first day, we can move on to the next part of the program. The first day, the user starts with however many pennies they specified, and the amount of pennies that they receive the next day is doubled. So it makes sense to keep track of these two amounts: how much money the user has and how many pennies they'll be given. Now, doing something for 28 to 31 days is repetitive, so let's use a for loop to iterate over the days in the month, updating the total and penny amount every time. For loop syntax contains the following: an initialization, a condition, and an update. Your for loop will initialize a variable when it first enters the loop. If the condition is met, the body of the loop will execute. Afterwards, the update will execute. If the condition is still met, the loop will execute and update and repeat, as long as your condition evaluates to true. Here's a for loop that divides an integer p by 2 a total of 10 times. Note how I declared the integer p outside of my for loop, so that the integer can be accessible outside the for loop. After the month has passed, it's time to tell the user how much money they've gotten. Per the spec, you need to tell the user how many dollars, not how many pennies, they have. But so far, you've kept track of the total and the pennies using long longs, which are whole numbers. There are 100 pennies to $1, so unless the number of pennies is a multiple of 100, you'll need to represent decimal places. The double data type allows you to do this. So how do we convert from representing pennies to dollars? Let's take a look at pi.c. This program takes a long, big pi, and divides it by 100,000 and prints the result to 5 decimal places. If we wanted to display 4 decimal places, then we can just replace this number here. So let's save, compile pi, and then see the result, which we expect to be 3.1415, the first 5 digits of pi. It isn't, though. And why? Well, because big pi is a long, which is a whole number, which won't keep track of decimals. The modification I need to make is in the division. I need to cast to a double here before dividing, because doubles can't keep track of decimal places. And I'm going to add a new line here for better formatting. And here we have it, 3.1416. You may notice that it prints 3.1416 instead of 1415 as expected. That's because it rounds during the division process as opposed to just truncating the value. Now you should be able to print the final total correctly, which finishes the program. Congratulations! My name is Zamila, and this was Pennies.